most of you know the answer to this by the amount of advertisements I've put out, but can anyone tell me what is the leading cause of serious long-term disability in the U.S.?
I got it. Stroke.
Correct. So I'm going to start out with what exactly is a stroke. So there are two different types of strokes, but they both basically lead to the lack of oxygen and blood going to the brain. The first type being similar to a heart attack where there are blockages in the blood vessels leading to the brain, and then the second type being hemorrhagic, which is when a blood vessel is bursting, going to or in the brain. So the symptoms of a stroke are numbness of the limbs, loss of vision, headache, speech difficulty, and loss of balance. And this can also, this is not only a symptom, but they can also continue into the aftermath of stroke in stroke survivors, as well as they can lead to more serious disabilities in the future. So the paper that I'm going to be talking about today tries to end all of these symptoms and restore functional recovery in the brain. So the paper is titled Dual Function Injectable Angiogenic Biomaterial for the Repair of Brain Tissue Following Stroke, or more simply, Injectable Gel Promotes Functional Recovery After Stroke. So what the researchers did in this paper was similar to what they did in the Hallmarks of Cancer paper if you took honors bio. So they basically made 5 hallmarks of a stroke, and then they engineered ways in this injectable gel to fix the 5 hallmarks. So the first being building a new extracellular matrix, 2 being reducing inflammation, promoting angiogenesis, which is just promoting blood flow, promoting neurogenesis and axonogenesis, which is basically just new immature neurons and immature axons in the stroke cavity, as well as testing for functional recovery. So actual behaviors that they were testing this in mice, the actual behaviors that the mice were exhibiting after they administered the gel. So first off, they built an artificial extracellular matrix with the base of the gel. So they chose a hyaluronic acid base, which they basically chose because it matched well with the brain's non-fibrous structure. So compared to other muscles in the body, the brain has less structure holding it together. So the hyaluronic acid was able to adapt to this environment. And they, when they injected this into the brain initially, it didn't change the size of the stroke cavity when tested at 2, 6, and 16 weeks post-stroke. And then they also saw that it wasn't accompanied with neurogenesis, angiogenesis, or axonogenesis, so they needed to add more things to it in order to fix. And then all of this step and all of the steps after this were tested at 2, 6, and 16 weeks post-stroke to test for the maturation period of tissue and the chronic period of tissue, so the tissue growth and then the tissue function. Any questions so far? So then next, they wanted to reduce inflammation in the stroke cavity, so they did this by engineering heparin nanoparticles. And what the heparin nanoparticles did were they activated the vascular endothelial growth factor, or VEGF, which is the main angiogenic growth factor in the brain. And so after they engineered this, they measured the level of macrophages, which are phagocytic white blood cells, so they are there when the immune response is present. So they measured the levels of macrophages and glial cells, which are cells that insulate neurons and insulate axons in the brain. So as you can see, in the gel plus HCV column is the gel with the heparin nanoparticles. You can see the significant difference between that and all of the other gels that they tested, and that GFAP is that was the glial cell stain, so you can see that that's significantly lower, and you can also see that the overall scar thickness was lower as well. Any questions? Yes, Dr.
So is the scar is made up of glial cells in this case?
Yes, glial cells, and the part of the immune response was the macrophages that they were testing for as well. So then next, they wanted to promote angiogenesis. So for this, they actually found that the heparin nanoparticles were working to also help angiogenesis. So they tested different concentrations of the heparin nanoparticles, so low, medium, and high. And of course, they found that the high concentration of the heparin nanoparticles, it's a tongue twister. The high concentration was the most effective at promoting angiogenesis. So they measured the vessel infiltration into the stroke cavity, and as you can see, the gel plus HCV was significantly higher than all of the other gels that they tested, and the penetration angle, which is kind of just another way of measuring the infiltration, it did show a significant difference in this case. And then another interesting point is that they actually had they compared the stroke cavity to the other side of the brain, just like the normal functioning half, and they found that at the end of the study, the vessel network was actually greater and more mature than the other side of the brain. So they were able to really significantly promote angiogenesis into the stroke cavity, which was pretty cool. So the next step was to promote neurogenesis and axonogenesis. And so this is the data that shows the axon growth, and they didn't actually have to do any more to the gel. They found that the heparin nanoparticles promoted angiogenesis, and with the angiogenesis, this actually came with more axons and neurons. So the NF was the stain that they used, and so you can see that the axons covering the vessel surface, that was significantly more, and then also just the overall area of the axons was greater as well. And then you can see in this, in these photos, that the stain, in all of the other gels, you can still see kind of the area where there aren't many axons, aren't many neurons growing, but then in this, it doesn't even look different from the surrounding area. So you can see that the maturation of the neurons and the axons was just really permeated the stroke cavity as well. So then, at the end of this gel engineering process, they looked at just the stroke volume as a whole, and so what that means is just what I previously showed you of how integrated all the different cells were into the stroke cavity, and you see that the gel with the HCV, it was very, very small, which is awesome, and it shows that the stroke cavity was significantly decreased. And then the number of migrating cells was also very high, so that shows that the angiogenesis, neurogenesis, axonogenesis, most cells were migrating to grow kind of a new area of the brain and restore the structure that was previously there. Any questions? So this is just another photo that shows kind of the diversity of cells that were then in the area after the study. So the NF green is the neuron staining and the axon staining, and then the GLUT1, I believe it was the glial cells. Yeah, Mr. Maxwell.
Yeah, they're doing this in mice, is that
Yes.
right? Okay, yeah.
And then the DAPI was the red was actually the blood vessel staining, and then DAPI, I believe, was I actually forget what that was, but it was another kind of cell that showed the diversity of the brain environment at this point in the study.
DAPI standing for DNA.
For DNA. Okay.
So you should see the nucleus.
Yeah, let's
Do you know anything about the other gels that they tested?
So the LCV was the low concentration, and the regular VS was the medium concentration, and the endo, I forget what that is now, but it was a different method for, I think, reducing inflammation. That they just it only reduced inflammation. It didn't really do anything else. So they just kept testing and didn't promote angiogenesis or anything like that. And then the empty gel was just the hyaluronic acid. So then after they realized that the brain structure was restored, they wanted to test to see if actual behavior was achieved in the mice. So what they did was they tried to find tests that mimicked human behavior. So the cylinder test was with the mice looking for symmetry and how much they jumped up on the walls. And so the orange would be the group given the high concentration of pepper nanoparticles. And so you can see that that's significantly greater than the rest of the trials. And then the grid was seeing how much time, how like the mice would walk around and then grip the grid as well. And you can see that that was significantly lower because they would just like stop at a certain point and know that they just like wanted to stay in the same place. So. And then the pasta, they measured the time it took for the mice to eat a piece of pasta, and then the amount of time it took was significantly lower, so they ate the pasta faster. And then this was a different piece of pasta that they had to like adjust every time they ate, and so the adjustments were way higher, so they knew that they had to like adjust the pasta to eat it more easily. Yes, Dr. Kirkland?
So the orange is the gel that we've seen works the best. But can you tell us, is one of those untreated, the other colors, is one of them the gel without any of the particles?
I think the gray is the empty gel.
Okay.
I have a question, kind of along those same lines. So like, are the orange lines kind of what you would expect as normal mouse behavior or healthy mouse behavior? Or
No, that was the observed.
they're just like, this is just what happened.
Yeah, it's
Okay.
just a comparative to all of the other gels.
Okay.
I wonder how fast a normal is.
I know. Like, how grippy is a normal mouse? I don't know.
So this is just a summary of the results. So increased angiogenesis, axonogenesis, physical barrier, and inflammation are kind of hand in hand, and then behavioral, an increase in behavioral recovery happened as well. So are there any final questions?
So it sounds like, I don't know if this was addressed in the paper, but so they looked a lot at the actual anatomy of it, and they looked at behavior. Do you know if they looked at function of the cells? Like, did they record from them electrically? Did they see if they were firing or look for anything like that?
I don't believe so, but I'm not entirely sure. I could look at it again and see. I don't know.
Just curious. Because you see both ends. I was wondering about kind of the middle piece.